Hello everyone, welcome back to our channel. I'm Perry, one of the MTC execs. Today, I'm excited to introduce Abhiraj Singh, the newest member of Math Together Canada. This video kicks off his full series on the 2025 AMC 12B solutions, where he'll walk you through each problem step by step. Enjoy the video and welcome Abhiraj to the team.
So we can just start off with question one. Question one is that we have a 350-gram bag of coffee beans, and we need to see how many mugs we can make, where each mug requires 20 grams. So we can divide 350 by 20, and that's giving us 17 with remainder 10. Since we want full mugs, we properly brewed large mugs, we can just go with 17, which is B. We can double check this by seeing that when we multiply 20 times 17, that uses up 340 grams, and we're left with 10 grams, which won't be enough to brew another mug. Moving on to question 2, we can look at the first 10 numbers mod 10 and their squares. So looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 mod 10 is 0, so we'll put that down. We'll square each of these and take their last digits, giving us 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. And we know this repeats for all integers mod 10 because the ones digit is mod 10, and then the last digit of 1 squared is going to be the same as the last digit of 11 squared and 21 squared and so on. So using this, we can see that the sum of the first 10 adds up to 45. And we know that 1 through 10 repeats 202 times, from 1 to 10, all the way up to 2010 to 2020. 2011 to 2020. So we have 45 times 202. But we also have to think about the next 5 positive squares, which are going to be 2021, 2022, all the way through 2025. And these are going to be the same as the last digits of 1 through 5. So we just have to add up 1, 4, 9, 6, and 5. So that gives us 45 times 202 plus 25, which gives us D, 9115. Moving on to question 3, what I would do is I would pair up the outsides. So I would do I times I minus 3, and then multiply that by I minus, and then multiply that by I minus 1 times I minus 2. This will give us negative 1 minus 3I times, and then I squared minus 3I plus 2 gives us negative 1 minus 3I times 1 minus 3I. And we can just use difference of squares here, with giving us negative 3I squared minus 1 squared, which gives us 9I squared minus 1, or negative 9 minus 1 equals negative 10, D. So we can continue on to question 4. It says that the value of the 2-digit number AB in base 7 equals the value of the 2-digit number BA in base 9. Transforming these into their base equations, we have 7a, because 7 to the power of 1 times a plus b is equal to 9 to the power of 1 times b plus a. So we have 7a plus b equals 9b plus a. This transforms into 6a equals 8b, or 3a equals 4b. So we have a couple different thingies that satisfy this. We have a equals 4, b equals 3, or a equals 6, a equals 8, b equals 6. But the problem with the second one is that since we're in base 7, all the digits have to be between 0 and 6, because if there was an 8 there, then that would be carried over. So we know that this solution is impossible. So then we know the answer must be a equals 4, b equals 3, which gives us a, 7. Moving on to the next one, what we can do here is that we can let the least possible value of x plus y be a, or b. We have x plus y equals a. Since we have x plus y equals a, we can set y equals a minus x. Plugging that into the original equation, we have 57x plus 22 times a minus x equals 400, which simplifies to 35x plus 22a equals 400. Since we know that x and y have to be positive integers, a must also be a positive integer. Since a has to be a positive integer, we can divide everything by 5, giving us 7x plus 22 over 5a, 22a over 5 equals 80. That means that 22a over 5 has to be a positive integer, meaning that a must be divisible by 5. Let a over 5 equal b. We have 7x plus 22b equals 80. You can go through a couple solutions for this and notice that we can iterate through values of b, noticing that if b equals 0, there is no solution for x. If b equals 1, there is no solution for x. If b equals 2, there is no solution for x. If b equals 3, we know that 7x plus 66 equals 80. 7x equals 14. So then x equals 2, and then if x equals 2, then b must be equal to 3. And since a over 5 equals b, a equals 15, which it gives us the answer e. We can also double check the two values, which means that x equals 2 and y equals 13. Now, moving on to the next question, what we can notice here is that we can let the price in cents be, we can multiply all of this by 100, since each thingy has to have a number of cents. This will give us all integers, and the integer total cost will be ABBA. So we know that ABBA must be divisible by 36. So we can first use the 9 divisibility rule, which means that 3b plus 2a must be divisible by 9. We also know that it has to follow the 2 divisibility rule because 36 is divisible by 2. That means that a has to be divisible by 0, 2, 4, 6, or 8. We can use something that we used in the last problem where we knew that since all of these numbers have to be integers, 3b plus 3b is divisible by 3, and then 9 is also divisible by 3. Dividing everything by 3, we know that b plus 2 over 3a must be divisible by 3. So we know that a has to be divisible by 3 for that equation to be a whole number. So since a has to be divisible by 3, and it also has to be even, we know that a equals 6. And now we just need to find a b such that 10b plus 6 is divisible by 4, and 3b plus 12 is divisible by 9. We notice that we can just go through different values of b, and we notice that one that satisfies it is b equals 5. So you have b equals 5 and a equals 6, meaning that a plus b equals 11. Moving on to the next problem, this is a logarithm problem. So we can first try to simplify the inside equation. We have log 2 of n plus 1 over n, where n plus 1 is is together. Log 2 of n plus 1 over n divided by log 2 of n times log 2 of n plus 1. Since we have this expression, we can first use one of the logarithm rules we know. We know that log 2 of n plus 1 over n can be simplified to log 2 of n plus 1 minus log 2 of n. Using this, we have log 2 of n plus 1 minus log 2 of n over log 2 of n times log 2 of n plus 1 times log 2 of n plus 1. Well, we can separate the numerator, giving us log 2 of n plus 1 over log 2 of n times n plus 1. Over log 2 of n times log 2 of n plus 1. We can simplify stuff here to get that this simplifies to 1 over log 2 of n. We can do the same with the other side, minus log 2 of n over log 2 of n times log 2 of n plus 1, to get 1 over log 2 of n minus 1 over log 2 of n plus 1. So what we're looking for here is that this will telescope, because log 2 of n and log 2 of n plus 1, when we move on to n plus 1, the log 2 of n plus 1, it'll cancel out. So the series in total will look like 1 over log 2 of 4, 1 over log 2 of 2, minus 1 over log 2 of 3, minus 1 over log 2 of 3, plus 1 over log 2 of 3, minus 1 over log 2 of 4, plus 1 over log 2 of 4, minus 1 over log 2 of 5. And so on all the way until plus 1 over log 2 of 255 minus 1 over log 2 of 256. So all of this will cancel out because it'll telescope, leaving us with 1 over log 2 of 2 minus 1 over log 2 of 256, which is 1 minus 1 over 8, giving us 7 over 8, equals C. Moving on to the next question, we have that all of these have to be integers, that this is a polynomial with integer polynomials. So for 4 plus root 5 to be a root, we need that 4 minus root 5 as its conjugate has to be there, or else it'll have rational numbers as its coefficients. So we have x minus 4 minus root 5 times x minus 4 plus square root of 5, so that we can difference the squares out the square root of 5. This simplifies to x squared minus 8x minus 21. Now we know that we have a third root, as this is a cubic, so we can let this third root be p. We can expand this expression to be x cubed minus px squared minus 8x squared minus 21x plus 8px plus 21p. So what we have here is that we know that x cubed minus px squared minus 8x squared, that corresponds to negative 5x squared, meaning that p equals negative 3. Since p equals negative 3, we know that ax equals negative 21x plus 8px. X plus 8px. And since from this equation we got that p equals negative 3, we have a equals it's x squared minus 8x minus 11 over here. So then we can plug that back in, 11p minus 11x. So then we have x equals negative 11x plus 8px, giving we have a equals negative 13. We can do the same with b, using that b equals negative 11p. And since p equals negative 3, b equals 33. A plus b then equals 20, which is C. With this question, we want to look at the last two digits of 6 to the power of 6 and 6 to the power of any power. So 6 to the power of 1 is just 0, 6. 6 to the power of 2 is 36. 6 to the power of 3 is 216. Now we can subtract 200 and just work with 16. 16 times 6 is 96. 96 times 6 gives us 576. So we just work with 76. 76 times 6 gives us 56. 56 times 6 gives us 336, and we work with just 36. And now we notice that this goes back to this. So we know that the first term, we know that we can index all of these terms, giving us 1, 2, to the power of 3, power of 4, to the power of 5, to the power of 6, to the power of 7. We know that the second power must always correspond with the seventh power. So we know that using that, we know that each of so that we can track this and we can retcon this to be 56. Since we know that for any power past 1, it'll be like when it's the 6th power, the 11th power, and the 21st power, it'll act as 56. And we know that we aren't looking at 6th power of 1, we're looking at higher powers of 6. So we know that if the power is 1 mod 5, we have 56. 2 mod 5, 36. 3 mod 5, 16. 4 mod 5, 96. 5 mod 5, 76, and it goes back to 6 mod 5 being 56. So we just have to look at what the power is mod 5. We know that the power is 6 to the power of 6. Taking that mod 5 gives us 1 to the power of 6, which means the power must be 1, meaning that the last 2 digits must be 56. So the answer must be C. Now this geometry problem, we can use a couple different techniques, but the one I'm going to use is chord bashing. So we can move to Desmos to continue doing this problem. So with this, we plot out all our points. We know that BC, we have CB, the point of the 90-degree angle, angle CBA equals 60 degrees, and angle CAB equals 30 degrees. Adding in the lines, since we've added all the lines, we have our triangle fully. Now we want to add the point of the midpoint. And since we know that this is -1, 0, and this is 0 square root of 3, we know that the point must be -1 over 2 square root of 3 over 2. And we can label this E. And we want to find out where the line DE where the line AE intersects CD, or the y-axis. So deriving the line equation, we have that the rise is -√3 over 2, and then we have the run is 7 over 2. So we get the slope must be -√3 over 7. Using this, we have y equals -√3 over 7x, and we move this up to so that it'll intersect with A, which means that we plug in 3, 0 into this, giving us -√3 over 7x plus b equals 0. So -3 over 7 plus b equals 0, so then b equals 3√3 over 7. So this gives us that this point is 0, 3√3 over 7. We can label this F. And we just want the ratio of either FD over CD or CF over CD, depending on which is smaller, FD or CF. We know that the value of CD is square root of 3. And then since FD is 3√3 over 7, we have 3√3 over 7 over root 3, which means that our answer is 3 over 7, which should be option A. So that's questions 1 to 10.